Okay guys, so we are looking at the notes, T7. I heard some people say that a few of these were a little bit confusing, so I'll go ahead and do number 1 with you here. The first thing we're going to look at is we're going to identify A, B, C, and D. So the values just go in order like that. The first thing we're going to be looking at is a shift to the left or to the right. So if we have something in the parentheses, that is always going to be a shift in the horizontal direction. So which way is this going to shift? To the right or to the left? To the right. So this is going to start at pi over 2 in our x coordinate. So now I'm going to have to find the period. The period is always going to be equal to 2 pi divided by b. So what is that if I have 2 pi divided by 1/2? 4 pi. So the period is 4 pi. 4 pi is how long it's going to take for this to start repeating itself again. So I'm going to have to take this period of 4 pi and divide it by 4, and I get pi, and that's how much we're going to add on each time. So Brittany, can you tell me if I add on pi over 2, what I would get if I add on a pi to that? Okay, you can just leave them out there. I'll give them in just a minute. Okay? 3 pi over 2, good. Keep going. Good. Good. Great. Okay, so that is correct for our x's. Now we're going to identify whether we're using sine or cosine. I also like to do this, though, before I go to sine or cosine. I like to say I've already taken care of this and this, because those affect the x's, so those are done. So now we're going to look at sine. Abby, what are the sine values normally going to be, those key points? 0. Good. Okay, so those are normally our key points. But then we're going to have some changes. Jared, we have to take all those values and multiply them by -3. Can you tell me what we would get then?
0, -3, 0.
Right. So now I've taken care of the change with my A. The last thing I'm going to take care of is the change with the D, whether we're going to go up or down or whatever. So Jacob, what are we going to do with that? So I'm going to add 2 to all my y's. So 2, add 2, all the way through. And now it's just a matter of plotting those points. So at pi over 2, we're going to be up 2. At 3 pi over 2, we're down 1. At 2.5 pi, we're up 2 again. At 3.5 pi, we're up 5. And at 4.5 pi, we're at 2. And then we just connect them. And then I just like to check. This should have been a shift up 2. I can see that it is. If I go like this, see how I can see that's a shift up 2. It was also a flip. The amplitude changed to 3 from here to here. I should notice that. It's been flipped. So I'm just kind of checking all this out just kind of quickly. And yeah, it all works out. Okay? Questions? All right, let's go down to the tangent graph. How do we graph the tangent graph? Well, it tells us to use our graphing calculator. So just turn on your graphing calculator. If you have anything in there, just clear it all out. Go to y equals. And you're going to type in tan x. When we're graphing the trig functions, we want to always check our mode. It's best if we're in radians. Anytime you're graphing a trig function, sine, cosine, tangent, anything, what we should do is we should do a zoom trig. So number 7 is a trig. And here's the way the function looks. All I'm going to expect you to do on our next quiz is be able to graph the tangent and cotangent and secant with your calculator. Okay? So notice here where we have some vertical asymptotes. What do you think the vertical asymptotes, where are they occurring? And? Good job. He's correct. At negative pi over 2 and pi over 2. Here's the reason why. Just a real quick explanation as to the reason why. This point right here is 1, 0. This point is 0, 1. Negative 1, 0. 0, negative 1. Okay? If I'm at negative pi over 2, that's right here. Tangent is opposite over adjacent, or y over x. That's undefined. At negative pi over 4, that value for tangent, that's going to be opposite over adjacent again. That's going to be negative 1. At 0, y over x is going to be 0. Pi over 4, the tangent value of 45 degrees is positive 1. And at pi over 2, y over x is going to be undefined. So that's the reason why we end up getting these asymptotes here, and here, and here, forever. And then I just look at my basic shape. At negative pi over 4, we're at negative 1. Here we're at 0, then we're at positive 1. This is that basic shape. Okay? But again, I'm letting you use your graphing calculator, and I'm also letting you, you can draw those pictures to kind of figure it out. All right, let's look at secant now. How does secant look? What's secant the reciprocal of, everybody? Cosine. So to graph secant, I have to do 1 divided by cosine x. And instead of just hitting graph, I always like to just do zoom trig, just to make sure that my window's set up correctly. And here's the way the secant curve looks. Okay, it looks kind of cool. It's a bunch of u's. They're not truly parabolas, even though they look like it. Parabolas are only when we have squared. So here's the reason why it's going to look this way. At secant is the reciprocal of cosine. So right here, what's our cosine value? 1. Pi over 2, what's our cosine? What about pi? 3 pi over 2? 2 pi? 5 pi over 2? 0 again, and 3 pi is right here, negative 1. Alright, so this is our points. We can go ahead and plot those if we want. At 0, we're at 1. Pi over 2, we're going to be at 0. But we're doing secant, not cosine. I just did cosine. So the cosine curve, we already know. It would have looked like this. Would have continued like that. So the secant curve actually comes up here, and it's going to look a little bit different. It's going to be the reciprocal of this. So what is the reciprocal of 1? Just 1 still. The reciprocal of 0 is undefined. This is negative 1. This is undefined on the reciprocal. And wherever we have an undefined value, that's where we're going to get our asymptote. So at pi over 2, we had an asymptote. At 3 pi over 2, an asymptote. Anywhere we had a 0, we're now going to have an asymptote. When we graph the reciprocal, it's just going to go in the opposite direction. So in blue, that's the way the secant looks. Okay? But that's kind of an explanation why it looks the way that it does. You would not graph the red part. I'm just showing you the red part to kind of explain why it looks that way. Because look, guys, if I have a reciprocal, let's say that this right here is 1/10. It's very, very small. That's my value right there is 1/10. What's the reciprocal of 1/10? 10. So that's why it's way, way up there. See what I mean? That's why it looks that way. Okay, we're not going to graph cosecant and cotangent. Again, just do it on your calculator, look at the charts, etc. All right, let's flip over to the back. We're looking at arc sine and arc cosine and all of this. When we're doing arc, we're looking for a single answer, okay, with the ratio of y over r, x over r, whatever it may be. For arc sine, arc cosecant, and arc tangent, the interval for all of our answers must be between negative pi over 2 and pi over 2. Let me show you what that looks like. Here's negative pi over 2, here's positive pi over 2. What quadrants then would those be representing? Quadrant 1 and 4. You should remember doing this in pre-calculus as well as in algebra 2. So this is review. From 0 to pi, that's here to here. What quadrants are those? 1 and 2. So looking at the first example, my answer has to be either we're doing arc sine, so it's going to have to be in quadrant 1 or quadrant 4. If it's a negative ratio, which quadrant is that going to put it in? 1 or 4? 4. So I draw my picture in quadrant 4. This is going to be -1, this is 2. So what's the reference angle in degrees? 30 degrees. Now, here's where people mess this up. A lot of people say the answer is 11 pi over 6. And you can see why they would think that. If the problem had been sine theta equals -1/2, and you were supposed to go in between 0 and 2 pi, like in our warm-ups, the answer to this problem would be 7 pi over 6 and 11 pi over 6. We just did that in our warm-ups. But for this case, everything kind of gets changed. Arc sine, our answer, must be in between -pi over 2 and pi over 2. These answers are not in between -pi over 2 and pi over 2. So what am I going to call this then, going this way? -pi over 6, very good, -pi over 6. That's going to be the answer for this. Okay, let's try this one now. Arc cosine. Our cosine, we look at our quadrants, 1 or 2. We have to be in between 0 and pi. Which quadrant am I going to put it in if it's negative cosine? Quadrant 2. Draw a picture. This is -1, this is 2, this is radical 3. What's the angle going to be? The reference angle. Everybody, 60. So now we just have to give this answer in radians to get our answer. What's it going to be, everyone? Do you know it? Excellent. 2 pi over 3. Okay, you guys try number 3 now. Dominic, what'd you get? Nope. Chase, what do you think? Dominic, do you agree? -pi over 4? Yep, that is correct. Here's the reason why. We've got to be in the 4th quadrant. Tangent is opposite over adjacent. That's a 45-degree reference. We have to look back at what we need to call it. Arc tangent, we have to be in between these values for our answer, so -pi over 4. Okay? Seem familiar? All right, let's skip down. Let's do a quadrantal one. Let's skip down here to number 6. Arc cosine of -1. Guys, whenever we see answers like 1, plus or minus 1, 0, or undefined, anytime we see those kind of answers for sine and cosine, we know we have to be quadrantal. So this is saying then that x has to be -1 and r would have to be +1. We got to think of the unit circle. Right here, this point is 1, 0. This point is 0, 1. This point's -1, 0. Where is it? On which axis or which radian measure is going to have x be -1? Hi, good job. So right here at pi. Okay? Do one more on your own. Let's have you do, actually let's do 2 more. Do 7 and 8 on your own. With your neighbors if you have it. Okay, so you should have it by now. These should be pretty quick problems. Lydia, what'd you get for arc cotangent of 1? Pi over 4 is correct. We have a 45-degree reference. And what about number 8? Maribeth, what'd you get there? Well, the only problem is, though, because of this negative. If you'd been in the first quadrant, you would be right, but we're in the second quadrant. So can you think of what it would be in the second quadrant? Good job. Okay, everybody get that? 5 pi over 6? Correct. All right, guys, let's look at this last one. This is a real-world application of the sine and cosine curve. It says on February 10th, 2012, high tide in Boston was at midnight, and the water level was 9.9 feet. The water level at the next high tide, 12 hours later, was again 9.9 feet. The low tide water level, which occurred in the middle of the high tides, was 0.1 feet. The curve representing the data is given by a sine or cosine curve. Find an equation for the water level as a function of time. All right, so here's what we're going to do. We're going to make a little chart here. So we're going to count midnight as time 0. And it says 12 hours later, it was again 9.9 feet. So what we're going to think about now is those y values. So we know that this was 9.9, and it said at midnight it was 9.9. Okay, so what about halfway in between? 6 hours? Okay, let's see what it says. So think of the tides. So we've got a high tide, and then we have a low tide, and then we have a high tide. So the low tide is going to occur halfway in between, so this is going to be 0.1. Halfway in between here, it's going to have to be in the middle of 9.9 and 0.1. So to find the middle of something, we just add and divide by 2. What do you get if you add those two together? 10 divided by 2 is 5, so these are 5. So this is what we've got then. So we've got to think of some things here. We've got to think of any shifts. Do we have any shifts to the left or right? No, we're starting at 0. Okay, so let's just take care of the x's first. We know that if we want to find that b value, we have to use this formula, that the period equals 2 pi divided by b. So what is the period here before it starts repeating again? 12, good. So it's 12 equals 2 pi over b. So I cross multiply, I get 12b equals 2 pi. I divide by 12. I get b equals pi over 6. Okay? So we've got pi over 6 then is our b value. Now we've got to think of whether this is sine or cosine. So look at the pattern here. Remember for sine, the pattern goes 0, 1, 0, negative 1, 0. For cosine, the pattern goes 1, 0, negative 1, 0, 1. Which pattern is this? Sine or cosine? Cosine. So I already know that this function has to be y equals, and I know it has to have a cosine. Right there, you got 2 out of 5 points just by putting that. Okay, now we need to think of some other things. We didn't have a shift to the left or to the right, but we do have a change in the period. See, guys, it always goes A, B, C, D. We have no C. We have no shift left or right. But we do have a B value. So B is what has to go in front of the X, like that. Next, we have to think, did we have a shift up or down? If this is cosine, these are supposed to be zeros, but they're not. So what was our shift? What is it, guys? Up 5. So then I know that I had to go up 5, like that. Now, what about the amplitude? The amplitude is the distance from here to here, or the distance from here to here. So what's the difference between these two? 4.9. And so this is our function. Now, this is the coolest thing, is that I can now check this function. Watch how we can do this. We're taking this quiz. We've got a calculator in front of us that we can check it on. 4.9. cosine of pi over 6